exponential functions. An exponential function is in the form of y equals some number to the power of x. Okay, so this is going to, our graph is going to grow exponentially. So exponentially is kind of like a parabola, but it's going to flatten out on one end. So for instance, when I'm looking at this exponential graph here, this is going to flatten out to almost a linear line, but then it goes exponentially up in my positive direction. So that's just a kind of preview of the exponential function. We're actually kind of working with the start of this and looking at how to simplify stuff that have a power that's a number. This is kind of going back to simplifying radicals and dealing with our exponents. So you're going to have to kind of maybe look back at those notes and kind of refresh your memory, because that's what we're going to be doing. So for this first example, I'm going to have 4 to the power of square root 2 times 4 to the power of square root 6. Well, I know that when I have 2 common bases, aka the 4, I can go ahead then. Normally we'd add these, but because it's simplifying with our radicals, we have 4 to the power of square root 12. Now, we can simplify the square root of 12, so then we have 4 to the power of 2 square root 3. Some of you are probably thinking, okay, how'd you get 2 square root 3? If I have the square root of 12, I know that can break down into the square root of 4 and the square root of 3. The square root of 4 breaks down to 2. That's where we get our 4 to the power of 2 square root 3. Like I said, this is going back to review of what do you know about your powers and how do you know to simplify radicals. So let's do another one. Let's say that I have 64 to the power of square root 7 divided by 2 square root 7. Now, they don't look the same, and I'm not going to take 64 divided by 2. Before, on that other example, we had 4 and 4. Well, that's my whole goal. I need to get the 64 down to a 2. This is where you're going to kind of have to play around with your powers on your calculator to know that 64 is 2 to the power of 5. Sorry, not to the power of 5, to the power of 6. Square root 7 divided by 2 square root 7. Okay, so this time, because our square roots are the same, my powers are the exact same, where before they were 2 and 3. So this time I can actually just subtract. This is going back to your rules here. So my answer is 2 to the power of 5 square root 7. Okay, this one's for you. I have y to the power of square root 3, which is now to the power of square root 12. Go ahead and try to complete this. Okay, because my powers are not the same, I'm actually going to multiply them, so I get y to the power of 36. Well, we know that the square root of 36 is 6. All right, so then there's the property of equality for exponential functions, and it states b to the power of x to the first, well, subscript first, equals b to the x2 if and only if x1 equals x2. Okay, so this looks kind of goofy, and we're actually going to do some examples with this. So let's say that I have 3 to the 4th equals 27m minus 1. Okay, so remember back to that second example where we had 64 to the square root 7 divided by 2 square root 7. I had to change the 64 to 2 square root 6. The same thing applies. Generally with all of these, you know that you're going to have to break it down to whatever number that you need. They'll be the same number for these. So I know that 27 is going to break down to 3. I need to figure out though to what power. And you can find that out on your calculator. You can just go 3 to the first, you know, is 3. 3 squared is 9. Okay, 3 to the third, that's 27. So I have 3 to the third. I still have this m minus 1. Notice I leave the m minus 1 behind it. And now I'm going to, because of the property of equality for exponential functions, aka this top line, my b's are the exact same. They're both a 3 in this case. So then I know that my exponents have to equal each other. So 4 then has to equal 3 times m minus 1. Well, now I just have to solve for my m. So 4 equals 3m minus 3. I'm going to add the 3 over. 7 equals 3m. And divide by 3. M therefore has to equal 7/3. Okay, we're going to do another one before you guys are let loose on your own. Sorry, I'm having some issues with my calibration. I have 16 to the power of 2n plus 1 is greater than or equal to 1 over 32. Okay, so I need to get this 32 and 16 down to the same power. 16 is 2 to the 4th, and then I've got the 2n plus 1 left behind, is less than or equal to 1 over 32 is really 1 over 2 to the 5th. And what happens with that, if you want to get rid of the fraction, it's really 2 to the negative 5th. So I have 2 to the 4th times 2n plus 1 is less than or equal to 2 to the negative 5. Well, like our last example, I can cut out that 2. So I have 4 times 2n plus 1 is less than or equal to negative 5. So now I can go ahead and solve this. I'm going to distribute. So I have 8n plus 4 is less than or equal to negative 5. Move the 4 over. 8n is less than or equal to negative 9. And then has to be less than or equal to negative 9 over 8. Okay, so for the last one, I gave you easy numbers to work with. You have 4 to the power of x plus 1, which then equals 8 to the power of 2x plus 3. Give you a hint. Think about how you can get to 4 and think about how you can get to 8. They have to be the same number. All right, so I know that 4 has to be broken down to 2 to the square, so x plus 1 equals 8 is really 2 to the third. 2x plus 3. Okay, I can cut out the 2's, so I have 2 times x plus 1 equals 3 times 2x plus 3. Okay, I'm going to distribute. 2x plus 2 equals 6x plus 9. I'm going to move that 2x over, so 2 equals 4x plus 9. Move the 9 over, negative 7 equals 4x. Therefore, x has to equal negative 7 over 4. Final answer. Don't be too stressed about this. We're going to work on more problems together in class. Bring questions if you have them to tomorrow or to the next class. That way we can talk about what you are struggling with.